Hello viewers. In our session for today, we are going to discuss about one of the easiest inverse Laplace transform. When you've been given a function like this one, the first thing that you need to understand is that we are going to use the partial fraction in finding the inverse Laplace transform of our function here. And by the partial fractions, this is what I mean. The inverse Laplace transform of 5 s squared, we subtract from 2s 19 all over s plus 3 into s minus 1 squared is going to be equals to the inverse Laplace transform of a all over s we add to 3. Here we are having a repeated root, and now we are going to have plus b all over s we subtract from 1 plus c all over s we subtract from 1 squared. That is on the repeated root. Now we need to get the values of a, b, and c. And by finding the value of a here, we can use cover up rule. But here we cannot use the cover up rule since it is a repeated root. What if in case it was given this way? On finding the value, here now we were supposed to find the values of a and b only. And by finding the value of a, we are going to use cover up rule, and finding the value of b, we are going to use the cover up rule. But since it has been squared, we cannot use the cover up rule to find the value of b and c. That one cannot happen in partial fractions. Let us get the value of a, cover up rule. For us now to get the value of a, we are going to have a s plus 3 is equals to 0, to mean that s will be equals to now negative 3. We come and write limit of s approaching negative 3 into 5 s squared. We subtract from 2s, we subtract from 19 all over. We are going to cover this term here, and now we are going to have s we subtract from 1 squared. Let us now insert our limit, because we understand that s approaches negative 3. And now we are going to have 5 into negative 3 squared. We subtract from 3, 2 into negative 3. We come and subtract from 19 all over negative 3. We subtract from 1, everything squared. Here we are going to have 9. 9 when we multiply by 5, we are going to have 45. We add to a positive of 6. We subtract from 19 all over. Here we are going to have a negative of 9, a negative of 4, sorry. When negative 4 has been squared, we are going to have a positive of 16. Our numerator, we are going to have 32 all over 16. 16 goes here to 2 times. To mean that the value of A, our value of A is equals to 2. That is how we use cover up rule to get the value of A. Let us now find the value of B and C. A was equals to 2 by using the cover up rule. Let us now get the value of B. 5 S squared we subtract from 2, S we subtract from 19 all over S we add to 3, S we subtract from 1 squared is going to be equals to A all over S we add to 3 B all over S we subtract from 1, we come and add to C all over S we subtract from 1 squared. We want now to find the value of B and C using the partial fractions. To mean that we are going to take whatever we are having here on the denominator, we multiply by this function, by this function, by this function, and by this function. And by doing that, this is what I mean. When we take our denominator here, we multiply by this function. S, we add to 3. We come and multiply by S, we subtract from 1 square. These two, the whole of this and this one will cancel out. And when we take the same function, we come and multiply by, here now we are going to have S, we add to 3 into S, we subtract from 1 squared. This function we come and multiply by S, we add to 3, S, we subtract from 1 squared. And this function we come and multiply by S, we add to 3 into S, we subtract from 1. When we take our denominator here, we multiply by this function, you are going to find that this one and this one will cancel out. In our second bracket, to mean that now when this one and this one have cancelled out, we are going to have 5 S squared, we subtract from 2S, we subtract from 19, is going to be equals to our function here, we multiply by whatever we are having here. These two are going to cancel out and we are going to be left by S into S, we subtract from 1 squared. This is what you are going to be left with at this point. We come and add to B. Here we are having two functions squared. To mean that at this point we are having S minus 1 into S minus 1. These two we can write them as S squared. 1 of S minus 1 is going to cancel out with 1 here, and we are going to be left with S, we add to 3 into S, we subtract from 1, because one of them is going to be cancelled by this denominator. Here we are going to cancel out, whatever we are having here is going to cancel out with our function at this point. And now we are going to be left by S plus C into S, we add to 3. Let us now get the values of A. Let us now find the values of B and C. Before we get the values of B and C, we must first open the brackets here and work out these two functions here. 5 s squared, we subtract from 2s, we subtract from 19 is going to be equals to, here we are going to have a into s squared. When you open this function, when you open this bracket here, because it is s squared, we are going to have s squared, we subtract from s multiplied by a negative of 1, we are going to have a negative of s, we multiply by 2, and now we are going to have 2s, and here we are going to have a positive of 1. We come and add to b into, here we are going to have s squared, s multiplied by s, we subtract from s, we add to 3s, and then we subtract from 3. And lastly, the value of c, now we are going to have, we come and add to c into s, we add to 3. In this second bracket here, we have a negative of s, we add to this one to mean that here we can have a positive of 2. We come and add to 2s. Let us now open the brackets. Let us now open the bracket here using the values of a, b, and c. We are going to have 5 s squared, we subtract from 2s, we subtract from 19 is going to be equals to a s squared, we subtract from 2as, we add to a, we come and add to, here we are going to have bs squared, we add to 2bs, we subtract from 3b. And lastly, we are going to have a positive of cs, we add to 3c. We can now get the values of b and the value of c, because the value of a we already have. For us to have the value of b, we can come and say, for us to have the value of b now, we can come and take the term of s squared. And by taking the value of s squared, we are going to have 5, because here we are having 5 s squared is equals to a has got a term of s squared, we come and add to b. By using the cover up rule, we say that the value of a was equals to 2 here, to mean that 5 is going to be equals to 2, we add to b, and now the value of b is going to be equals to 3. 3 is equals to now the value of b, to mean that b now is equals to 3. Let us now define the value of c. C has got a term of s, and then we can have a constant. When we are using the term of s, it can help us in finding the value of c. Here we are going to have negative 2, because it has a coefficient of s, is going to be equals to negative 2a s, and here we are going to have a positive of 2b s. We come and add to c. Or you can decide to use the constant. When you check at the term of a constant, we are having 3c, and here also we are having our constant, and here also we are having our constant. So you're going to take negative 19 is equals to a negative 3b, you add to 3c, and then you insert your value of a and b to get the value of c. But here I'm going to use our function, our terms of s. Negative 2 is going to be equals to negative 2. Our value of a is equals to 2. We come and add to 2. The value of b is equals to 3. We add to c. Negative 2 is going to be equals to negative 4. We come and add to 6. We add to c. Here we are going to have the value of a positive of 2. Negative 2 is equals to, here we are going to have a positive of 2, sorry, because we have negative 4. We add to a positive of that. C is going now to be equals to, C is equals to a negative of 4. Finally, we have the value of C, which is equals to a negative of 4. Now we have all the values of A, B, and C. We agree that the inverse Laplace transform of this function is equals to whatever we are, the inverse Laplace transform of our partial fractions on the right hand side. To make that the inverse Laplace transform of A all over S, we add to 3, plus B all over S, we subtract from 1, plus C all over S, we subtract from 1 squared is equals to the inverse Laplace transform. Our value of A is equals to 2 all over S, we add to 3. We come and add to, our value of B is equals to 3 all over S, we subtract from 1. We come and subtract, here we are having a negative of C, which is equals to 4 all over S, we subtract from 1 raised to a power of 2. We can now find the inverse Laplace transform of these functions, all of them, directly, because we have now the value of A, B, and C. And by finding the inverse Laplace transform of this function, we understand that we are going to distribute the inverse Laplace transform to each and every function here. And now we are going to have the inverse Laplace transform of 1 all over S, we add to 3. We come and take 3, we factor out the inverse Laplace transform of 1 all over S, we subtract from 1. We subtract from 4 the inverse Laplace transform of 1 all over S, we subtract from 1 squared. After distributing the inverse Laplace transform to each and every sign, using the first principle, we agreed that the Laplace transform of exponential positive or negative at was equals to 1 all over S, negative or positive of A. This is what we agreed on. To mean that when you check out this function and this function, they matches whatever we are having here. But when you check at our function here, it doesn't match this function. We agreed that using the first shift theorem, we agreed that the Laplace transform of exponential positive negative at we multiply by t is equals to, we agreed that we first get the Laplace transform of t, and the Laplace transform of t is equals to 1 all over s squared. But since we are using the first shift theorem, it means that the term of s must be, the term of s at this point must be shifted. And by shifting the term of s, we are going to have s negative or positive of a, because we are shifting with respect to our term of a, and here s was squared. To mean that when we check at whatever we are having here, it matches our function here. Let us now have our answer. Here we are going to have 2. The Laplace transform of this function is going to be exponential exponential when we are having here a positive of a, it means that on the numerator here we are going to have a negative of 3t. We come and add to 3 exponential. Here we are having now a negative of 1. It means that the coefficient of t is going to be now a positive of t. We come and subtract from 4. And now we are going to have t exponential. Here it was shifted with respect to a negative of 1 to mean that now the value of the value of a is going to be a positive, because we are having here a negative. And this is how you go about a function like whatever we've been given here, using the partial fraction to find its inverse Laplace transform. Thank you for your time.